For examples 3, they want us to do the following stuff. More take the derivative. So say find y prime. Part A, they give me y equals natural log of x cubed plus 1. And part B, y equals natural log of square root of sine of x. Okay, so natural log is the outer derivative, so I'll take its derivative, which is 1 over x, but instead of the x, I'm going to replace x cubed plus 1, the inner function left alone. So take the derivative of natural log, that gets me 1 over, it's the inner function left alone, and then I multiply that by the derivative of the inner function. So this, when I simplify it, so it's a chain rule I'm using again in order to get this. For this one, I have to use a chain rule twice. So y prime, it's 1 over the inner stuff left alone. And then we need to take the derivative of the inner stuff. So to take the derivative of square root of x, it's 1/2 to the negative 1/2. And we leave the inner part of that alone, which is sine of x. Then we have to multiply out here by the derivative of sine, which is cosine. So that's the chain rule twice. Rewriting it nicer gives me, well, I guess we got 1 over square root of sine x. This negative 1/2 of sine of x goes downstairs also. Cosine stays up top, and the 2 gets multiplied down there. So if we work on simplifying that down, we get this is equal to 1/2 cosine of x. Square root of sine times square root of sine is square root of sine squared, which the square cancels the square root, so this is just over sine. And then cosine over sine is cotangent. So my derivative eventually simplifies down to this. They wanted us to also say, what if you tried to take the derivative of natural log of some function of x that you don't know? Well, natural log's the outer function. So it'll be 1 over the outer function left alone times the derivative of the inner function, which we could say is that. And then we could write this cleanly as an equation. And we'd get this. So you can either memorize this, or if you know the chain rule, this is just kind of a result of the chain rule. So if you want to memorize it, you can. If you just kind of want to remember how the chain rule works, you can generate this equation pretty easily. Next little bit here, we're going to use a change of base formula. And then we got some other tricks we're going to do in a couple examples after that. So we'll say for this one, the change of base formula is log base b of x equals log base a of x over log base a of the old base b. So if they give us, say, for this example here, example 4, they want us to find derivative of log base 10 of x. Well, I'm going to use the change of base formula up there to convert this to natural log. So derivative of log base 10 of x is the derivative of its natural log of the thing in parentheses over natural log of the old base. This right here is a constant, so I can push it out front. So it'll come out front like that. And then if I want the derivative of natural log of x, this will be 1 over natural log of 10. ddx of natural log of x is 1 over x. So simplifying it, I get that.